الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is objective 4. Use factoring to separate different functions in trigonometric equations. We have studied 3 objectives in this section. And now we will study equations like this. If we have 2 different trigonometric functions, and if we can move one of them to the other side, so we move all terms to one side, and we can take tan x as a common factor. So if you take tan x as a common factor, you will get sine square of x minus 3 equals to 0. Then either tan x is 0 or sine square x equals 3, which means sine x equals plus or minus square root of 3. Square root of 3 is 1.7, and sine x is a number between -1 and 1. So it cannot be equal to positive or negative square root of 3. So this equation has no solution. So the only equation we have is tan x equals to 0. And looking to this figure, if you remember, we know that tan 0 is 0, tan pi is 0. So there are 2 solutions of this equation, and the solution set consists of 0 and pi only. Let us solve also this equation. If you take sine x to the other side, and then take sine x as a common factor, you have tan x minus 1, not minus 0, because I have already sine x. So if you take sine x as a common factor, you still have 1 there. So either sine x is 0 or tan x is 1. And you have 2 equations, you can solve them. Sine x is 0. You can solve it here. Sine is y, so sine x would be 0 when you have 1, 0 and -1, 0. So the 2 solutions are 0 and pi for this equation. While here, if you use tan inverse of 1 would be pi over 4. So the reference angle you are talking about is pi over 4. We have 4 angles with reference angle pi over 4, but the tan is positive in the first quadrant and in the third quadrant. So the solutions would be pi over 4 and 7 pi over 4. So x here is pi over 4 or 7 pi over 4. I mean 4 pi over 4, sorry, because this is 4 pi over 4. So if you add 1, you get 5 pi over 4. 7 pi over 4 is here in the fourth quadrant. So there are 4 solutions, 0 and pi over 4 and 5 pi over 4. Some questions from the book. Solve each equation from 0 to 2 pi. This is already factored. This equation is already in the factored form. So either this is 0 or this is 0. Then you have cosine x equals negative square root of 3 over 2, or sine x equals negative half. And you write the solutions here and the solutions here. If you find cosine inverse of negative square root of 3 over 2, you will find the angle 5 pi over 6. So this is, by the calculator, it's 5 pi over 6. What is important for me that the reference angle is pi over 6. Cosine is negative, So I am in the second quadrant and in the fourth quadrant. So the two solutions would be 5 pi over 6 and 7 pi over 6. So x here is 5 pi over 6 or 7 pi over 6. While here, if you find sine inverse negative half, the calculator will help you to determine the reference angle. The calculator says negative pi over 6. So the reference angle is also pi over 6. Sine is negative, so I am here and here in the third and the fourth quadrant. So this angle 11 pi over 6 is the other solution. So here the solutions of this equation are 7 pi over 6 and 11 pi over 6. So the solution consists of 5 pi over 6, 7 pi over 6, which is repeated. It's the solution of this one and this one at the same time, and 11 pi over 6. Notice that negative pi over 6 is not an accepted solution, is not accepted as a solution because it does not belong to this interval from 0 to 2 pi. That's why you don't depend on the calculator. The answer of the calculator may be a solution and may not be a solution, like here. This question is nice. Please, when you review the section, always review this question. Here, I can take sine x as a common factor. So I will have 1 plus 2 cosine x equals 0. So either sine x is 0 and I can solve this equation, or cosine x is negative 1 over 2. Now, sine x is 0, as we have seen. Sine is 0 here and here, because sine is y. So the solutions of this equation are 0 and pi. You can ask for cosine inverse negative half. It is 2 pi over 3. So by calculator here, x, if you use cosine inverse negative half, the calculator says 2 pi over 3. What we get from here, that the reference angle is pi over 3, but cosine is negative. So if cosine is negative, we should deal only with this quadrant and this quadrant. So one of the solutions would be 2 pi over 3, and the other solution would be 4 pi over 3. So x here, 2 pi over 3 or 4 pi over 3. And the solution set of this question, there are 4 solutions: 0 pi, 2 pi over 3, and 4 pi over 3. And as usual, you can check any of these answers. You can replace x by any of these answers and make sure that the answer is correct. Here, if you take tan square x to the other side, and then take tan square x as a common factor, you will have cosine x minus 1 tan square x times cosine x minus 1. Then either tan square x is 0, which means tan x is 0, or cosine x is 1. Now tan x is 0, as we have seen here and here, because y over x. So the solutions of this equation, 0 and pi. Cosine x would be 1. Cosine is the x coordinates, so it is 1 here. This is the only place in which cosine is 1. So the solution of this equation in x is 0, because here we have 0, 1, here we have 0, negative 1. So the solution set of this equation consists of 0 and pi. 0 is the solution of this equation, and it's also the solution of this equation. So when you write the solution sets, you write it once. Good. Now, the last objective is how to use a calculator to solve trigonometric equations. When the reference angle, is not pi over 6, pi over 4, or pi over 3, then you have to use the calculator to find the solution. And once you find the solution, always you will get from the calculator the reference angle. So you use the reference angle to find all other solutions. So in fact, we have been using the calculator here. So you will do the same, but you don't know the reference angle immediately. You have to find the reference angle, as we shall see. So we shall see. Solve each equation correct to 4 decimal places. Again, from 0 to 2 pi. Tan x equals this number. So immediately you say that x would be tan inverse of this number, okay, 0.8044. Now go to the calculator and ask for tan inverse of 12.8044 and be sure that you are in the radian mode. So the answer is 1, he says to 4 decimal places. So let us deal with 4 decimal places. So 1.49285, so it would be 9. So 1.4929. Now what is this? This is the angle in radian, okay? This is the angle in radian. Now tan x is positive. We will search for solutions here and here in this quadrant and in this quadrant. And I need the angles with reference angle equals to 1.4929. Okay, that's the reference angle. So this angle, of course, remember pi over 2, pi is 3.14. So if you approximately, if you divide pi over 2, you get 1.57. So this number is 1.57. So 1.49 would be somewhere here, okay? This angle is 1.4929 radian. So this is a solution. And we need the angle in the third quadrant with reference angle equals to 1.4929. So this angle is the angle I need to find. Okay, how can I find this angle? I just add pi to this number. So pi plus 1.4929, you can just ask the calculator to add pi, and 1.4929, the answer is 4.63449, so I'll make it 5. So the solution set in this question consists of two numbers, 1.4929, this is the first angle, the angle in the first quadrant, and 4.6345, and this is the angle in the third quadrant. So these are the two solutions of this equation. Another example, cosine x equals a number. You go to the calculator and you find cosine inverse of negative 0.4317. Cosine inverse of negative 0.4317. The answer is 2.01717, so I'll make it 2. We need 4 decimal places. Please pay attention. Remember, pi over 2 is 1.57. This is 2.0. In this question, the angle was 1.49, was less than 1.57. So it was the reference angle. But here, the answer is 2.0172. and this is a number here. This is 2.0172. It's greater than 1.57. So it is not a reference angle. You cannot deal with it as a reference angle. Where is the reference angle to this angle? Because why 2.0 is here? Because this is pi, and pi is 3.14. So 2.0 is greater than 1.57 and less than 3.14. So this is the angle 2.0172. I need the reference angle of this angle. This is theta prime. This is the reference angle of this angle. So what is theta prime? What is the reference angle? It is pi minus 2.0172. So it would be pi minus 2.0172, 1.12439, so I'll make it 4. So this is my reference angle. Okay. Now cosine is negative, so my solutions should be in this quadrant and in this quadrant. Now the solution in the second quadrant is 2.0172 because it has this reference angle. But now, what is the solution in the third quadrant? Well, I need this angle. This angle would be the solution. And to find this angle, how can I find this angle? I know the reference angle. This reference angle is 1.1244. So how to find this angle? I add pi, because this is pi, plus 1.1244. So this would be the angle in the third quadrant with reference angle equals to 1.1244. And that would be 4.2659. So it would be 6. 599 in fact, so 60. So the angle, the solution set here consists of two angles in radian. The first one is 2.0172 and the second one is 4.2660. These are the two solutions. This is how we should solve these angles, okay, or these trigonometric equations using the calculator. Please try to solve this one. And here are the two solutions, and also this equation, and here are the two solutions. Also, this is an exercise, and these are the two solutions. This is another exercise, and the solutions are given. So please work at home, practice, and let me solve this equation for you. Solve this equation correct to 4 decimal places. This is a quadratic equation that's a quadratic, which is a quadratic in form. So to solve this equation, I try to factor. So sine square would be sine x times sine x, and minus 1, I cannot factor this equation. This equation cannot be factored. All right, what to do? I should use the quadratic formula. What is the quadratic formula? A is 1, B is -1, C is -1. Quadratic formula says sine x equals -b, which is 1, plus or minus square root of b, b square, which is 1, minus 4 times a times c over 2a. So it's 1 plus or minus. This is 1 plus 4, so square root of 5 over 2. So I have two equations. Either sine x is 1 plus square root of 5 over 2, or sine x is 1 minus square root of 5 over 2. Now, how to solve this equation? I use the calculator. X would be sine inverse of 1 plus square root of 5 over 2. And the answer is math error. Good. Again, why it's math error? This number must be greater than 1. So if you just ask 1 plus square root of 5 over 2, it is 1.6. So this number is 1.6. So we said that sine x is a number always between -1 and 1. It cannot be 1.6. So this equation has no solution. While here, x would be sine inverse of 1 minus square root of 5 over 2. Now try to use the calculator to find this answer. The answer is negative, the calculator says negative 0.6662 if I deal with 4 decimal places. Now this is x. As usual, I need the reference angle. This is a negative angle in radian. If you go in negative direction, this is negative 1.57. So negative 0.6 would be somewhere here. This is the angle negative 0.662. What is the theta prime? What is the reference angle of this angle? It is the positive angle, 0.662. So this is the reference angle, 0.6662. Now, which quadrants we are dealing with? Sine x is equal to this number. Is this number positive or negative? What is 1 minus square root of 5 over 2 equals what? Equals negative 0.6. So this is a negative number. So my solutions would be either in the third quadrant or in the fourth quadrant because sine is negative. So how to find the solution in the third quadrant? I need this angle, which is the reference angle, 0.662, and I add pi. So pi plus 0.662 would give you one of the solutions, the solution in the third quadrant. And this solution is 3.8078. The other solution would be here, okay? And how to find this angle up to here? You take 2 pi and subtract the reference angle from 2 pi. So 2 times pi minus 0.6662, you will get 5.61698. So it would be 7. I have 7, 0. So the solution set of this equation would be 2 angles in radian, 5.6170 and 3.8078. Please, the last question, you can solve it similarly, and also these 2 or 3 or 4, even 5 questions, all are similar. I stop here, and inshallah, I receive your questions soon.